Okay, this one here is a digital timer that's connected to this little unit here, from which I'll drop this ball here onto the pressure pad. We used to measure the acceleration due to gravity with that, and I calculated for this distance here, which is 89.5 centimeters. I should come up with 0.427 seconds, and when I drop this one here, and if you want to come over and then in a moment measure the time, film the time, there we go. Careful, don't step on the wall here. As I said, it should measure 0.427 seconds, and this is the second time around that we are measuring 0.447 seconds, and that's an error of about 5%, which I actually wrote on here that it's 5% too much. That's why it says subtracted. And so that's a large systematic error, and if I kept this running here, then it would just measure, well, compared to a stopwatch, it would be like 5% off. It would measure 63 seconds instead of 60 seconds. Okay. Then let's see what else I got. Oh, spring scale, the next one. So here I have a random error. I put this weight on here. By the way, I want to show the systematic error. Notice that this one is not at 0. So I have to push this tag a little down, and now it's at 0. However, if I hold it horizontally, you can see it again, because now it's not, the spring isn't pulling on it anymore vertically. Now it's way off, so I have to recalibrate it. And if I don't pay attention to that, I have produced a large systematic error. That's what I mean by whenever I produce a systematic error, it's one that I also could get rid of. Now when I turn back to the vertical, whoop, way off again. So depending on how I measure vertically or horizontally, I have to recalibrate it back to 0 to avoid that systematic error. Now when I put this piece of zinc on here, I come up with, well, my mass looks like 62 grams. Perhaps I want to give it, that's the closest I can read, plus minus a couple of grams, or my weight would be 0.63 newtons, somewhere in that neighborhood. And if I put it actually on a scale, which is able to measure more accurately, like this one says 60, yeah, pretty much 65.0 grams. That one is of course more accurate. This one here is a few dollars, but the scale here, or the balance here, is kind of like $120 we determined earlier. And that of course I cannot send along. Okay. Okay, actually last one I got is thermometer reading. Oh, I forgot to show that earlier. That again, also here, depending on what kind of how accurate your thermometer is, I could read maybe here 22.5 degrees Celsius, and I could say plus minus half a degree Celsius because it's in between those divisions. Okay. I got boiling water here, and at what temperature does water boil?
100 degrees Celsius.
100 degrees Celsius. Okay. And see if you can film this here as the mercury goes up there. Okay, and can you see at what temperature water boils? You can, yeah, you can look past the camera. You see it? See that? There's the mercury.
Looks like it's 108.
Yep, 108 Celsius. That's a little odd. I think you are right in saying that water should boil at 100 degrees Celsius, and when I put this in here, this other thermometer, it actually does read 95, 96, 97, 98, 90, yeah, 99 Celsius. We give it that 1 degree. That's probably because the actual water here might just cool off a little bit, not be exactly 100, but the steam is at 100. Oh, it's pretty close, 99.5. Mm-hmm. So what's with this other thermometer? Well, I used this thermometer the first time 15 years ago when I started out teaching, and one of the groups read that water boils at 109 Celsius. Okay, that was actually in Nebraska, and they read 107 degrees Celsius because we're in a higher elevation, but still way off. And if you look here at the divisions, I don't know if this will film, then we can, or the numbers, then we can see there's 50, there's 60, there's 70, there's 80, and there's 100. That means the manufacturer, for some odd reason, produced a bunch of these thermometers with the 90 missing. Nice systematic error that if I know about it, I can get rid of. And that concludes my videos on random errors that we always have in any kind of measurement. What we can do is we can try to minimize them, but we always have to acknowledge that there is at least a small random error. And then systematic errors that if we know about them, we can get rid of them, as I demonstrated with the meter sticks just a moment ago, with the thermometer, or not using a faulty timer and the like. Okay, thanks.